That's it. Okay. Well, hello everyone. This is Manas, your friend and tutor. And guys, today's session, or from today onwards, we are going to kick off a new lecture series on deflection of beams. Now, this video series is going to be very vital and important for all you civil and mechanical engineering students. तो चलिए शुरुआत करते हैं आज deflection of beams से. Let us try to work out what this exactly is and what are the basics that first needs to be covered before you start learning deflection of beams. Let us start with the basics. And over to the right of the screen, right of the whiteboard rather, you can obviously see this is a beam. And right now, this beam is sort of in an undeflected position, okay? Unloaded beam. This is an unloaded beam. Now, let's say we are loading this beam, okay? You may put on some point loads, you may put on some uniformly distributed loads also. What might happen? Just take a look. It's going to be very interesting. So this is the point and that's the point. So the initial position of the beam would be something like this. Now when you load this beam, obviously there is going to be a deflection, and this is that deflection, right? So this refers to a loaded beam. Okay, and what's happening? It is going to deflect. I'm not writing it entirely. Just try to understand the concept. And here we are having a simple, what you call a simply support here also. So what we essentially do in deflection of beams is that we calculate the deflections, vertical deflections to be very precise. Let's say you want the deflection at this point. Let me call this point as point number 1. Now the deflection in this point is from the original position was somewhere here. The deflection in this point is going to be referred to as y1, isn't it? Now the distance of y1 from any one end or any one end support, let's refer to this as x1. You'll get to understand why I'm telling you all of these things. Just keep watching. Let's say we want a deflection somewhere here, right at the middle. So the deflection at this point is going to be referred to as vertical deflection y2, and at this point, let's say this is rather at a horizontal distance of x2 from the rightmost support. So the idea is, if you have certain values of x, x1, x2, x3, then you should also have certain values of y, vertical deflection, y1, y2 and y3. So our idea, our objective in this particular chapter is to develop a sort of relationship y versus x, a relationship which is going to help us know this deflection for a certain value of x. Okay, so it's going to be very mathematical. You can say this, y is nothing but a function of x. For different values of x, let's say x1, x2, x3, ऐसा इक्वेशन बन के निकल के आएगा कि आप x1, x2, x3 कुछ भी रखोगे, आपको corresponding y1, y2, y3 मिल जाएगा. The equation would be such that on plugging in the values of horizontal distances, okay, at any point of the beam, you just pick this distance, put it up into this equation, you are going to get a value of the vertical deflection. Now this is the equation. This is the equation that we are concerned with in this chapter of deflection of beam. It's absolutely clear. Okay, so what do you do in deflection of beams? You actually work out an equation that is going to help us find the deflection at different points on a beam. That's it. Okay, मतलब एक ऐसा इक्वेशन निकल के आएगा जिसकी सहायता से आप बीम के किसी भी बिंदु पर, या फिर आप ऐसा कह सकते हैं बीम में यदि कोई भी बिंदु आप अंकित करते हैं, उस बिंदु पर कितना डिफ्लेक्शन आएगा, ये सारी बातें आप आसानी से कैलकुलेट कर सकते हैं. बिल्कुल ठीक. तो चलिए सेशन को आगे बढ़ाते हैं. लेट्स टेक दिस सेशन फॉरवर्ड. सो व्हाट इज द ऑब्जेक्टिव? द ऑब्जेक्टिव इज टू फ्रेम एन इक्वेशन. हाउ आर यू गोइंग टू फ्रेम दैट इक्वेशन? देयर आर सर्टेन मेथड्स. Well, the methods are in the form of double integration. Then we've got the very popular Macaulay's method. Then there is moment-area method, conjugate beam method, and then there is also a strain energy method. Very less popular, but it is very effective. Okay. Anyway, one more thing which I need to tell you. एक और बात, आप जो देख रहे हैं ना, ये जो डिफ्लेक्शन आपको दिखाई दे रहा है, इतना बड़ा डिफ्लेक्शन, यहाँ पे तो आपको साफ दिखाई दे रहा है डिफ्लेक्शन कितना है, साफ आपको दिखाई दे रहा है. जनरली जब इंजीनियर्स स्ट्रक्चर्स को डिजाइन करते हैं, उसमें बीम लगते हैं, कॉलम लगते हैं. Okay, so generally when engineers design structures, so they used to place beams, they used to place columns, and what you will realize that you won't be able to notice any sort of deflection. आप एक चीज़ ध्यान देना, आप कभी भी डिफ्लेक्शन को नोटिस नहीं कर पाएंगे, मतलब आपके जहन में आपको लगेगा कि नहीं वहाँ पे हल्का सा डिफ्लेक्शन है, ठीक है, हालांकि हो सकता है वहाँ पर डिफ्लेक्शन हो, वो परमिसिबल लिमिट्स में भी होगा, लेकिन आपको दिखाई नहीं देगा. डिफ्लेक्शन शुड नेवर बी नोटिसेबल. जो भी डिफ्लेक्शन होगा कभी भी लोगों के नज़र में नहीं आना चाहिए. अगर नज़र में आ रहा है तो उस इंजीनियर की नौकरी खतरे में है, ठीक है. सो मेक श्योर द डिफ्लेक्शन शुड नॉट बी नोटिसेबल. यहाँ पे प्रश्न को समझाने के लिए इन दिस इलस्ट्रेशन आई हैव बेंडेड दिस इनटू अ वेरी एग्जैजरेटेड फॉर्म. मैंने बहुत ज़्यादा ही डिफ्लेक्शन दिखाया है. असल में इतना डिफ्लेक्शन, इन रियलिटी दिस मच डिफ्लेक्शन डज नॉट हैपन. इफ इट हैपन्स, एज आई टोल्ड यू, देन योर जॉब इज इन डेंजर. Anyway, now we shall try to develop or devise a relationship between slope and deflection and all that stuff. You'll get to know what slope is, what is deflection. By now you know what is deflection, and I shall also let you know what is slope. Okay, just try to take this. So this was the initial position, isn't it? And that's the final position, right? Now let's say I want you to calculate the slope and deflection at this very point. So the slope would be a tangent. Just make a tangent. Whatever angle that this tangent makes with the horizontal, you want the slope at this point. Okay, make a tangent at this very point. Whatever angle this tangent makes with the horizontal, this angle is what is referred to as slope. This is pure mathematics. And as far as deflection is concerned, and this right over here is the deflection. ये तो यार हम सब जानते हैं डिफ्लेक्शन के बारे में, ठीक है. तो बेसिकली इन द प्रॉब्लम्स ऑफ डिफ्लेक्शन ऑफ बीम्स यू आर गोइंग टू कम अक्रॉस स्लोप एज वेल एज डिफ्लेक्शंस. यू मे बी आस्क्ड टू कैलकुलेट बोथ ऑफ देम. पहले स्लोप बाद में डिफ्लेक्शन और वाइस वर्सा, कुछ भी हो सकता है. तो चलिए सेशन को अब आगे बढ़ाते हैं. अब आज हम लोग क्या करने वाले हैं, व्हाट विल ट्राई टू डू इन टुडेज सेशन इज दैट विल ट्राई टू डेवलप अ रिलेशनशिप बिटवीन स्लोप, डिफ्लेक्शन एंड रेडियस ऑफ कर्वेचर, यू कैन से. ओके, सो लेट मी जस्ट ट्राई दिस relationships between slope and deflection. Today's session is going to be very short, guys, so ज़्यादा कुछ है नहीं, but in the next sessions we are going to be taking up some problems. Okay, so relationship between slope तो यार थीटा है, आप जानते हो, between slope and deflection, slope and deflection. Okay. Okay, let's start. Let's have one more figure. थोड़ा सा फिर से बनाते हैं इसको, कोई दिक्कत नहीं. यहाँ पे और ये यहाँ पे आ गया. Okay. So this is your deflected beam, isn't it? Supports कहाँ गए? Where are the supports? Here they are. Simply supported. Left end, and this is the rightmost end. Done. Now, what we'll try to do? Let me place 2 points here and here. These 2 points are extremely close to each other, extremely close, very very close. Let's say that the name of this very point, this is P, and let's say this is Q. Okay, what I'll try to do from here on is I'll pick up this curve and I'll zoom into it and I'll make it over here. मैं क्या करूँगा, इस छोटे से पोर्शन को उठा के यहाँ पे रखूँगा और जूम करके थोड़ा सा बड़ा करके इसको बना के आपको दिखाता हूँ, and then we'll analyze it. Okay, what we'll be doing is we'll pick this up and we'll keep it over here. We'll rather make a bigger figure and we'll try to analyze it and we'll try to develop a relationship between slope and deflection. Let's see. So उसके लिए क्या करना पड़ेगा आपको? What needs to be done is this. Here we go. Let me have a coordinate axis. Okay. Done. So where is the curve? कर्व को किसी और कलर से बनाए? नहीं, चलो रहने दो इसको. Let's make it with black. It's like this. The curve is like this. Okay, so I've made this much portion of the curve, let's say, and let me just mark 2 points, and those 2 points are in the form of, well, that's P, and let's say this is well, that's Q, right? Okay, so these are the 2 points. What are the slopes? What is the magnitude of slope as at these 2 points? For that, what we need to do is we need to make tangents. How are we going to make those tangents? Well, not that difficult. There is something like this. Okay, so this is your slope. Let's call this as alpha. Okay, we should be using a different color. Let's write alpha. Obviously, this point is slightly ahead of P, that is Q. So if you try to make a tangent at Q, it would be something of this sort. Okay. Let us make solid lines. Right? Anyway, so if you just take a look, the angle over here at this very point will be slightly more, that is alpha plus d alpha. Right? So just take a look at this point P. Let me circle this. Let me circle this Q also. So if this is the tangent, and if I were to make the normal would be looking something like this. And if you can draw a normal to this tangent also at this very point, normal to this tangent at this very point, it would be something like this, isn't it? The angle here is 90 degree, the angle here also is 90 degree. Anyway, these two are going to meet somewhere. Let's say that the meeting point is point C. So one thing is for sure, that the radius of curvature of this PQ arc is nothing but R. So let me just write this. Let us start the analysis. The first thing which we know from the diagram is that CP is equal to what? CP is equal to CQ is equal to radius of curvature. Okay, let me just write this. Radius of curvature. That's for sure. What else? Okay, one more thing. Just keep watching. This is going to get really very interesting. A bit of geometry, a bit of trigonometry, a bit of calculus, and I mean these are all the ingredients to have the final relationship. ठीक है? थोड़ा सा नमक, थोड़ा सा हल्दी, थोड़ा सा प्याज, सब्जी बन जाएगी बस. देखते रहें. So what now needs to be done is, guys, just take a look. This line and this line. So if you watch, if you have a triangle like this, if the angle over here is theta, and this 90 degree, this is the line, this is the line, this is the line, this is the line at an angle of 90 degree. So what happens if you just make a line like this, here, the angle that is going to work out is, also going to be theta, and here it is also going to be theta. This is simple geometry. That means the angle which we can write at this very point is alpha. That is quite obvious. And similarly, for this it was alpha, and for this it is going to be alpha plus d alpha. And that's R. Let me erase this right now. Okay, so if that is alpha plus d alpha and this is alpha, then obviously this much very small angle, this is going to be d alpha. That's for sure. Okay, now what? So just take a look. PQ. Now this PQ is very small, isn't it? So there is one assumption which we are going to make. Now guys, this assumption is going to be very important for applying a bit of trigonometry. What is this assumption? This arc PQ is almost equal to this line PQ. Now this is what we are going to be assuming. It's so small that this length of the arc can be assumed as a straight line. Okay, and based on this philosophy, what you can do is, let me just show that. I don't know, with green color, make a horizontal, make a vertical, right? This point. This is your change in Y, and this is your change in X. Just take a look at this. Take a look at this triangle PQ. Now PQ is no longer an arc. We are assuming this PQ as, or rather PQ to be a straight line. So this is PQ, and let's call this as point M. Let me make this triangle over here, sort of a bigger triangle. This way, this way and this way. Now, if you watch this right here, this angle over here, this is something which we need to work out. So if you've got two parallel lines and you've got a transversal, the angle here is theta, then this angle is also theta. Similarly, you've got two parallel lines, this and this line, PM, and you've got this transversal. If the angle here is alpha, the angle here also is going to be equal to alpha, that's for sure. So that is going to be alpha. In front of alpha, we have dy, isn't it? You can clearly see this is going to be dx, and this is obviously, let's call this as ds. The length of the arc, let's call this as ds. ds. We can write it here, ds. Okay. Now, let us apply a bit of trigonometry. Sin alpha. So what's sin alpha? Okay guys, opposite upon hypotenuse, that is dy over dx. What is cos alpha? Cos alpha is equal to base over hypotenuse, that is ds. Did I do something wrong? Base, what is d? Not s but x, that's dx over ds. And similarly, we've got tan alpha. Tan alpha is going to be equal to perpendicular, that is dy over base, that is dx. So these are the relationships which I'll be using in the upcoming analysis. Keep watching. अब क्या करना है जरा देखो, यहाँ पे एक सिंपल सा फंडा लगेगा. So if you watch, if you have an arc, that arc is going to definitely have a center. This is angle theta, this is the arc length, and this is the radius. So there is a relationship, theta is equal to arc over radius. So it can also be written as radius is equal to arc over theta, isn't it? Can we do this? Yes, we surely can. So just take a look at this. I'm going to be making this arc CPQ, only this much portion. So let's make this portion. Let me first enclose this in a rectangle. Okay, these are the results which I'll be referring to in the further analysis. Now, just take a look at this. This point over here is C. And that's the arc. Okay, so this is P, this over here is Q, and this angle right here is alpha. So if I were to make a relationship, what I'll do is radius r is equal to arc over theta. We know very well that this is nothing but ds and this is nothing but r. So you can use this relationship, r is equal to what? Arc, that is ds, over this angle, that is alpha. So r is equal to ds over alpha. Okay, not alpha, but what is that angle? It's not alpha. Let me write this as d alpha. So that is ds over d alpha. So this completes our analysis. Okay. Now there are a lot of things left. Let me cover them one by one. It's going to get easy. What we'll do is we'll divide the numerator and denominator by dx. Once you do that, you will have this r in this form. R is equal to ds over dx whole divided by d alpha over dx. So do we have a value? ds over dx. ds over dx. So we have x over s and we want s by x, isn't it? So this can be equated to, what we can write is this, we can write this as 1 by cos alpha. 1 by cos alpha. Just keep watching, and this is going to be divided by d alpha over dx. Let's proceed. थोड़ा जगह बना लेते हैं मेरे भाई. क्या पता. Alright, so r essentially is equal to sec alpha whole divided by d alpha over dx. What you now need is this value, d alpha over dx. How can that be achieved? You can achieve it from this. Tan alpha is equal to tan alpha. Let me use a different color. Tan alpha, just take a look. We know tan alpha is equal to dy over dx, isn't it? Let us try to differentiate this with respect to x. Once you do that, what you have is, this is going to become sec square alpha d alpha over dx is equal to d2y over dx square. Okay, so d alpha by dx, ultimately you will have this d alpha by dx is equal to 1 over sec square alpha dot d2y by dx square, and we are going to be using this result and putting it up into this. Let's start again. Blue color, get it out. R is equal to, we already have sec alpha, brilliant, divided by this d alpha over dx. What is d alpha over dx? It's 1 over sec square alpha, 1 over sec square alpha multiplied by d2y by dx square. You can also write this as sec cube alpha divided by d2y by dx square. And let me just make a reciprocal of this. Let me write this as 1 by r is equal to d2y by dx square, and let us just say that this is equation number 1. This is going to be beneficial for us. Let me tell you. Now, अब क्या करें? You must have studied bending of beams, okay, or pure bending, let's say. Pure bending equation. What is the pure bending equation? Because obviously the beam is bending. You can apply the pure bending equation. So if you can just recall, for a beam which is undergoing a sort of pure bending, you can actually use this relationship. Moment of inertia m upon I is equal to sigma by y. Sigma, by the way, is bending stress. Moment of this m is bending moment. This is moment of inertia is equal to E Young's modulus whole divided by the radius of curvature. Okay. Now, what I'll try to do is I'll try to equate these two, and from here what I'll get is this: 1 over r is equal to m upon EI, and this is exactly what we'll do. Let's say this is our equation number 2. Now I'll put the value of 1 by r is equal to m over EI into this equation, and the final equation which we are going to have is this. Let me just write it. M over EI is equal to d2y over dx square. You can also write this in a better fashion. It is popularly written as moment across the beam is equal to EI times of d2y over dx square. This is the very popular slope deflection equation, and it can be integrated to obtain the values of slope and deflection. So yes guys, that was all for today. I'll see you again in the next video with some problems based on double integration method, and let me tell you, one by one we'll be covering all the methods of beam deflection. We are going to kick off with the double integration method, which will be followed by the Macaulay's method, then strain energy method, then moment area, conjugate beam. I'll try to solve as many as problems and try to clear your doubts as much as possible. So yes, that was it for today. I'll see you again in the next video. Until then, take care, have a nice day, keep learning, keep watching, and thank you.